Welcome to the final session of gas stoichiometry with Miss Taylor. If you've been watching the video series, we've been piggybacking off of this same reaction. In this one, we are saying that 5 grams of potassium chloride were produced, and we want to know what volume of oxygen gas was made at STP. And hopefully you started to remember that STP is 0 degrees Celsius or 273 Kelvin and a pressure of 1 atmosphere. Okay, so for this setup, of course, we're starting from grams because that's what we were given. And the only place you can go from grams is to moles using the mole ratio. And I have previously calculated the molar mass of potassium chloride, which was 74.55. Now that we have moles of our given substance, we can convert to moles of our desired substance by using the mole ratio. Pardon my mistake there writing. And you can hear my cat Opal in the background meowing in protest that I'm not petting her. Alright, now that we have moles of O2, we can actually go directly from moles to liters because of the conditions of STP. So by definition, 1 mole of any gas at STP has a volume of 22.4 liters. So when you plug this into your calculator, you should do 5 times 3 times 22.4 divided by, use some parentheses, 74.55 times 2, and then close the parentheses, and hopefully rounding to 3 sig figs, you will get 2.25 liters of O2. Now, you may be wondering, well, what if we aren't at STP conditions? What would I do then? Well, let's say we want to know how much oxygen gas would have been made if we were at 1.5 atmospheres and 273 Kelvin. So, same temperature, not the same pressure. Okay, so the problem would start the same. We have to convert from grams to moles using molar mass. And then again, we'll use the mole ratio to get us from moles of given to moles of desired. But we don't have STP conditions, so we can't go all the way to volume. So we're going to have to get the number of moles here. And then, what wonderful thing will get us? Moles, or if we have moles, and temperature and pressure will get us the volume. Why, our good friend, the ideal gas equation. So we would plug in 1.50 atmosphere, looking for volume, 0.1006 moles of O2. Since this is atmosphere, we have to use 0.0821 liter atmosphere per mole Kelvin for our value of R, which is the ideal gas constant. And temperature is already in Kelvin, so we didn't have to convert that. So 0.1006 times 0.0821 times 273, then divided by 1.50, and you should get 1.50 liters of O2. Thank you for your attentions.